Hello, my name is Hamilton Chavez. I am part of the WebVR team working on the virtualization scenes of abstract data structures and sorting algorithms. Today I will be showing you the primary use cases of the system. The primary actor for the WebVR scenes project is the student. As a student, their use of the system is to have access to the platform via web access. Once they access the website, all they have to do is click on any of the associated View Scene buttons in order to be redirected to the virtual reality scene. If visiting the website on mobile, it is recommended to be viewing the website in landscape orientation mode for a better experience viewing the visualizations. Now let's click on a virtual reality scene to view. On the bottom right, you'll notice the VR mode button. This button is provided by the WebVR API. While viewing these scenes on a desktop browser and clicking on it, we enter full screen mode. However, if the user is using a mobile device and they touch this button, their headset will now go into VR mode.
Hello, I am Daniel Kawan, working on the WebVR towards virtual and augmented reality project. This is the first release of this project, and today I will be showing you the Three.js and WebVR API scene, and I'll also be showing the Canon.js demo. In both scenarios, the only actor is a single user, the person who is using the web page. If I refresh this page, a bunch of random blocks are selected, and then they are sorted using the selection sort algorithm. As you can see, the minimum is found, and then it is swapped with the current index. All the user has to do is refresh the page in this version, and they will get this scene. So a new scene will be generated every time. If you double click, you enter VR mode, and you use A, D, S, and W to look around. In the Canon.js demo, we have a physics engine that is being used. The user gets to press stack push to push onto a stack. This clearly illustrates the last in, first out property, especially when we click stack pop. So the user has the choice to click these. And if you get an empty stack, stack is empty. You can enqueue, and you can also dequeue with pointers to where the dequeuing was happening. And finally, we have a hash table with separate chaining collision handling. As for the other scenes, they have not been developed yet, but as you can see, the template has already been developed. Thank you.
Hello, my name is Daniel Rivero. I am a part of the WebVR game development team. I'm going to be showing you a use case for getting the robot to move forward. We first make the assumption that a module has been placed on the programming board. The main actors of this use case are the robot, the user, and the system. So the first thing that happens is that the robot detects the move forward module placed on the programming board. The robot then sends information about this module to the system. The user closes the programming board. The system generates a state machine based on the information received. The user runs the configuration on the board. The robot changes internal states from ready to running. The state machine transitions into the move forward state, and then the robot moves forward.
With the WebVR team, one of our main actors is the developer. The first thing the developer needs to do is to import SDL2. SDL2 will be used as the connection for the input devices that we'll be using. Next, I need to input the spatial input class as well as the devices class, which contains all the devices that are predefined for the developer. After this, we'll use events from SDL2 to figure out what's happening exactly with the devices. Right after that, input the input adapter, which is what allows the developer to add his or her predefined actions for the input. sub input and connection mode. So for now, the only connection mode is SDL and as well as client server. And with our main class, this is how you create your first input device. We'll create a new controller. The input adapter allows you to create a new controller using the connection mode SDL2.